Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 25th. I'm Mark Sponsler, and I'll be your host for tonight's presentation. We'll be discussing surface level pressure, jet stream level winds, surface level winds, significant wave heights, and of course long and short-term effects of the MJO and El Nino or La Nina, and how all this affects. We'll start off looking at significant wave heights for the South Pacific Ocean. We don't see a whole lot going on. A little bit of low pressure generating 22-foot seas off of New Zealand, but otherwise a pretty calm pattern is in play. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when those gales form, help direct their track. We're looking for a trough that is sort of like what's there, a little push in the southern, there's the southern branch of the jet, there's the northern branch. It's the southern branch that we're interested in. A little push to the north there. That helps create a clockwise flow aloft. And that's the hallmark of low pressure. It also manifests itself down at the surface. And of course, low pressure generates winds. Winds generate seas, and seas, as they radiate away from the fetch area, turn into swell. Swell, of course, when it hits your beach, turns into surf. So we see a trough here, but it's outside of the Southern California swell window. We're not really concerned with that, but otherwise you have this just generalized ridging pattern. It's going the whole way across the South Pacific from about 62 south the whole way down to nearly 70 south, and the ice line is at its seasonal peak right now, up at about 62 south. So basically, the southern branch of the jet sweeping right over the northern edge of the Ross Ice Shelf and Antarctic ice and doing nothing to help support gale formation. So we can put this into motion and see what's happening. You can see as we get into Monday, same basic pattern. Tuesday, no real change. Almost as you get into Wednesday here, you see something that's starting to try to look like a trough here south of New Zealand. Not particularly strong, being fed by was at 130 knot winds. And yeah, we'll call that a legit trough by Wednesday night, but it's sort of pushing to the southeast instead of up to the northeast. You really want to see the trough build and start lifting northeast. We're not seeing that, but yeah, maybe there'll be some support for gale formation. After that, winds start building as we get into Friday night and Saturday to 150 knots here under New Zealand. But again, right over that ice line between the Ross Ice Shelf and the Southwest Pacific Ocean. Probably not doing a whole lot for support gale formation. You just see this roll out into Sunday. We're a week out. Then another bit of a trough tries to organize, but wind's pretty weak. So in general, the pattern just not looking super good. And of course, it's late in the season, and you'd probably be asking, well, why aren't you talking about the North Pacific? Well, there's nothing going on there, and we'll get into that in a minute. So we're reaching, grasping for straws here. South Pacific Ocean seems to be the best opportunity to someone throwing a bone our way, and even at that, things not looking great. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. We see a little bit of an area of low pressure here east of New Zealand, 30 knot winds. That's not very much. And broad area 30 knot winds aimed due south. Another little patch of 30, 35 knot winds in the far southeast Pacific here. See if you can get that a little bit better centered. There you go. And the cutoff is right around, really there's just nothing going on. Let's just put this into motion. You see pretty much the same pattern, this low trying to develop, but just really small, cut off from the jet stream, not able to do a whole lot. Then finally we get into like Wednesday, a gale starts developing in that new trough we saw south of New Zealand. 50, I thought there was almost some 55 knot winds. There you go, 55 knot winds as we get into Wednesday morning. And clear of the ice line, just barely. Wednesday night, it's actually moving off to the east. This is better than even this morning's run of the model where the whole thing was just falling southeast. Now the gale, actually a storm, anything greater than 50 knot winds is a storm. The system is supposed to now push off to the east, maybe giving a little bit of hope for some swell radiating north. We're not betting on a lot, but you never know. And so that system fades out as we get into Thursday. Friday, another gale sort of tries to organize, but there's just not good jet stream support here, right? You got to have the trough. That's why we harp on this so much. You got to have a trough. You got to have good winds aimed to the northeast to get a real legit system. Here's another gale. Most of this fetch is probably over ice, 45 knot fetch as we get into Saturday, and that kind of fades out. Notice, look at the fetch here, 40 knot fetch, all just aimed due south, just doing nothing for us. And 180 hours out, a week and a day and a half a day, things kind of just aren't doing anything in the southern hemi. All right, let's go take a look at the wave models, see if there's somehow some magical hope that these winds actually are generating something or could generate something aimed in our direction. And we're going back in time just a little bit. This is Tuesday of last week. A small gale developed south of Tasmania, produced, 35-foot seas, peak seas over this entire area, 35-foot seas, and built a little bit while pushing up into the Tasman Sea, this region right here. Seas pushing 37 feet as we got into Wednesday, and then lifting north 28 to 30-foot seas into Thursday. This swell has already hit Fiji, pretty good size, probably pretty raw ones there. The point being, energy, let's see if we can actually see, you get the sense seas seeping around Fiji towards Hawaii. We'll just roll this out to current time. So swell is pushing towards the Hawaiian Islands. It might be a kind of reasonable size as we get starting later Monday into Tuesday, Wednesday, Thursday, even Friday. So a long run of small surf, small to moderate size surf for the Hawaiian Islands from a rather southwesterly direction, like 215 degrees. Doubtful any of that's really going to make it to the U.S. West Coast, though. And then we continue on looking. Here's today's model. We'll just sort of roll this out. Just looking for any 28-foot seas or greater over a decent-sized fetch area. You don't see anything until you get into Wednesday, that gale south or the storm south of New Zealand. 40-foot seas over a tiny area, and sort of tracking how much it moves to the east versus southeast, building into Wednesday night with now 50-foot seas. That's pretty impressive. The highest this was as of this morning was like 40 or 41 feet. And then continuing off to the east pretty good into Thursday with 49-foot seas. And then finally starting to scrape into ice line here and fading out. If that happens, maybe we could actually get a little bit of surf from it. At this point in time, we'll take anything. We're kind of in that weird time of the year where the southern hemi starts shutting down. There's not enough energy in the northern hemisphere to really get anything going because we're not in a strong El Nino pattern. No big tropical activity. We'll get into that in the long-term forecast, but we're kind of in this funky position where the North Pacific isn't really coming online yet. Okay, and as you see, we're into Sunday. We're just looking for anything pushing to the north. We're not seeing it. So maybe this gale on Wednesday is at least a little bit of hope for the California swell window. Otherwise, Hawaii has Tasman Sea swell to look forward to during the week. And now, as promised, the North Pacific Ocean. Here we are, 18Z on Sunday. Just looking for anything. There actually is a little bit of hope here as we wind this out, but so there is a gale that's forecast north of Hawaii. Not even a gale, we'll call it a low pressure system, generating 20-25 knot north winds. It'll create some seas pushing towards the Hawaiian Islands. Maybe, just maybe, a little bit of north wind swell will come into the north-facing shores of Oahu and Maui. Then this is actually looking better now, but of course it's Saturday. We're almost a week out. The small little gales forecast developing on we'll call it the North Dateline region, 24-foot seas, excuse me. Okay, and pushing off into the northern Gulf with 19-foot seas into Sunday and then fading out. If this were to occur, seems like a real long shot. We're talking a week out. That would definitely make rideable surf for the Hawaiian Islands and the U.S. West Coast whenever it arrives, probably just eyeballing it Wednesday or a week from Wednesday or Thursday. So nothing to get too excited about, but hey, at least there's something on the charts and we'll take it. We're desperate at this point. And then finally, the wind swell forecast. All right, Sunday, yeah, we had east trades pushing into the Hawaiian Islands, east wind swell along east-facing shores. And there was high pressure, 1028 millibar high, generates a clockwise flow. And as that high pressure starts bumping up against a heat low inland, creates a bit of a gradient, but we're talking only, and tightening of the isobars, 15-20 knot north winds off of Cape Mendocino. Yeah, there was some small winds, so what was it, like waist to maybe chest high and like Ocean Beach and San Francisco area. But You know, the southern hemi swell coming into exposed breaks in Northern California was probably bigger than the wind swell, so that doesn't say a whole lot. On Monday, fetch is supposed to build a little bit up to nearly 30 knots, so increasing odds for wind swell into California, while fetch dies for Hawaii and the wind swell fades out there. We get into Tuesday, and this fetch starts fading as the high starts dissolving. We know low pressure is on its way for that area. You can sort of see, here's the first little signs of low pressure north of the Hawaiian Islands. We talked about this on Wednesday. 20, 25 knot winds aimed right at the islands. Maybe some wind swell. And how far is that? Let's see. 1, 2, 3, 900 to 1,200 nautical miles away. That's pretty good distance for an 8-second period, maybe 9-second period wind swell to travel. We'll see. Maybe some wind swell for the Hawaiian Islands from this. And then it too fades out as we get into Friday. And you notice there's literally nothing along the California coast. So when we talk, we're in this dead zone. High pressure is losing control of the North Pacific. That cuts out the wind swell. But low pressure, here comes the first maybe semi-real low pressure system of the winter season for the Gulf of Alaska. But you know, most of the fetch is aimed to the north east. Not really at California, and certainly not at Hawaii. So, whoops, maybe some wind swell could result from that, but we'll see. We're not holding our breath. So, wind swell not giving us a whole lot of hope. So let's go take a look long term. What's going on with the Madden-Julian oscillation and El Nino or La Nina? Of course, the Madden-Julian oscillation, a periodic oscillation that travels on the equator from west to east. And we're really interested when the active phase of the MJO traverses the Pacific Ocean on the equator. That tends to fuel storminess. It imparts energy to the upper levels of the atmosphere, fuels the jet stream, and then in turn helps fuel storm development and swell production. And this happens both in winter months in the North Pacific and in our summer months in the South Pacific. So we start looking for the MJO, either active or inactive phase, using this chart, data from the TAO buoy array, mainly used for monitoring El Nino, but it can also be used for monitoring just winds and 5-day average winds across the equator. This is the East Pacific here, West Pacific here, New Guinea there, date line right there. It's this area right here in the far West Pacific area. We call the Pacific Ocean. We call this the Kelvin wave generation area. And if you get the active phase and west winds in this area, it takes warm water, 30 degrees centigrade water here, starts pushing it off to the east, and that can be a harbinger for the start of El Nino, but that's likely not going to happen anytime soon because we've been in El Nino or some flavor of it for a year and a half, 2 years, very weak one, and most of the energy we think is tapped out in the West Pacific. Anyway, so we have easterly winds, trades across the East Pacific, Central Pacific, and we have some westerly winds here in the far West Pacific in the Kelvin wave generation area. And anomalies, differences from normal for this time of year. Yeah, we have east winds, but they're not particularly strong. If anything, it's just kind of a neutral pattern. And we have this, we'll say, westerly anomalies in the Kelvin wave generation area, so maybe some tendency towards the active phase of the MJO, but nothing super strong. Next, we look at the forecast for the next 7 days, the next week. And so this is the whole planet on one chart. This is the, so 0 degrees, 180 is the date line. The Pacific Ocean then runs from about 120 east to about 90 west. So between these set of broad tick marks, but it's the Kelvin wave generation area that we're really interested in, from about here to about here. So you just go right up the chart. And this is past performance. So you see we've had this persistent westerly anomaly pattern. We had this, the purples are in the blues and the purples are east anomalies. That would be synonymous with the inactive phase of the MJO. That happened the first part of August, and that's what really stomped on. We had a good run of southern hemi swell pretty much all July into early August. Inactive phase, the MJO came, just destroyed the jet stream, wiped out the storm track. Now, since August 15th, you see there is westerly anomalies have been trying to build in the Kelvin wave generation area, but just not very strong. And here's where we are today, just kind of this dead neutral pattern mixture of easterly anomalies, westerly anomalies, none of it very strong, just a rather placid wind pattern in the Kelvin wave generation area. So let's go out 2 weeks. These models, outgoing long wave radiation, right there, OLR, basically a fancy word for cloud cover. If you have more clouds, and that's what the blues are, means less reflectivity off the ocean surface, more clouds. That's a good indicator of low pressure and the active phase, the MJO. The yellows, more reflection, less clouds, the inactive phase. But you look at this, it's a very weak pattern, neither active nor inactive. You just go down for the next 2 weeks. Looks like a basically dead neutral pattern forecast. This per the statistic model. You go look at the dynamic model, it's saying the exact same thing. So basically, if there's an MJO, it's very weak. Either way, no clear support in the jet stream for storm production for the next 2 weeks. Phase diagrams, basically saying the same story. This is the statistic model. This is the dynamic model. This circle here, assume you're looking down on the North Pole. The MJO travels from west to east on the equator, from like the Indian Ocean, over the maritime continent, Bali area, across the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back into the Indian Ocean. The heavy dot is where the active phase of the MJO is. So in the Indian Ocean, if it's inside this circle, it's considered to be very weak. So a very weak active phase. And the forecast, the three branches of the statistic model suggest that it's supposed to inch its way over the maritime continent, remain very weak. That for the statistic model, dynamic model, saying basically the same thing. So no hope there for the next 2 weeks. The 40-day model, upper level model, so this is basically gives you a sense of whether what your odds are for precipitation based on the MJO. Oranges and yellows, dryness, no precipitation. Consider that the inactive phase. Greens, the active phase, favorable for precipitation. So there's South America, Central America, and over here's, well, there's the equator. Date line's right about there. New Guinea, Australia, you get the picture. Okay, so inactive phase, leaving the Pacific, heading off into the Atlantic into early to mid-September, while a very weak active phase tries to inch its way into the West Pacific for the end of the first week of September and just sort of falling apart. So even at 40 days out, no good solid signs of the MJO. At least what we have is weakly active instead of weakly inactive. And here comes the inactive phase. It's looking to make its debut into the West Pacific Ocean maybe in early October. Let's dig a little deeper. The CFS model, okay, again, this is one of these deals. Whole planet on one chart, the area we're interested in, Kelvin wave generation area, fancy word for the West Pacific. So between this tick mark and about this tick mark here going up, here's where we are today. Here's past performance. When you see the reds, that's westerly anomalies. The more reds, if it's pretty good, and you have, let's see, we're the black circle. If this was all contiguous, say that's a pretty good active phase, the MJO there. Kind of faded out, inactive phase. Here's where we are today. Westerly anomalies, filling the Kelvin wave generation area, which is good. Weak westerly anomalies. Maybe some sort of a weak active phase trying to organize as we get into late August, early September. But still, just no strong MJO signal. Again, this is this theme of the atmosphere is just sort of like asleep. Yeah, we know fall's coming. Yeah, we know we're supposed to start changing towards a cooler regime, but there's nothing really just driving anything at the jet stream level. Just a very low energy pattern. Probably because we've been through our El Nino-ish like phase, and the atmosphere is just kind of, it's done its thing. It doesn't have any energy, and it's just weak. It needs recharge time. All right, one more model. And then the 3-month CFS model. Now this is different. Past performance is down here. The forecast is for the future. Whole planet on one chart, Kelvin wave generation area between these two tick marks going up. So basically this region in the chart right here is our forecast, the yellows and oranges, westerly anomalies. That's the good news. Westerly anomalies forecast to continue in the Kelvin wave generation area into nearly Thanksgiving. We'll take that, let's overlay the MJO. But here is the problem. Here is a, what we call modest MJO pattern. This was back in June and May. But look at where we are for now, the whole way through fall. Just this very lackadaisical, weak MJO signal. Yeah, a little active, a little inactive. Just can't can't make up its mind what it wants to do. Just a very low energy pattern. That's probably not super conducive to storm development, at least initially. I mean, as soon as you get into winter, things will wake up a little bit, supposedly, and you'll get more of a pattern. But we're not like rushing into fall with a lot of energy and the atmosphere just primed to start bombing. Not seeing that at all. All right, we overlay the low pass filter. The low pass filter gives you sort of sense of where El Nino or La Nina is. The good news is we have this contour, the solid contour, which is basically a low pressure bias. It's forecast, and this changed a month or so ago. It was supposed to die out, and the low pressure bias was supposed to die, and maybe even high pressure setting up in the Pacific, and the low pressure bias moving to the Indian Ocean. That would have looked very much like La Nina, but no. Now all of a sudden, at least the model has reversed itself and said, hey, low pressure bias supposed to continue in the core of the Kelvin wave generation area, and if anything, maybe rebuild a little bit as we get into the Halloween time frame and past that with two contour lines. Now, do we believe that? And is there any empirical evidence in the ocean that this might somehow materialize and magically wake the Pacific up? Well, that's what we're going to start getting into in a minute. Just sort of a placeholder here. This chart tracks the strength of the active phase of the MJO. It doesn't tell you where it is, just relative strength, historically speaking. So back here, let's go way back, January 2013, January 2014. Look at how this is a weak MJO signal. Then we got into a real El Nino in January 2015. You see big spikes of the active phase of the MJO up to, I guess this is 3 standard deviations and beyond 4 standard deviations. And then as we got into 2016, things slow. We got a spike here in 2017. Another one in 2018, but now here we are in 2019. You see this sort of just a steady downward trend in the strength of the MJO. Really smells like we're moving back towards maybe not this bad, but something maybe more in the 2016 time frame, something like that. Just historically speaking, kind of a weak MJO pattern setting up. All right, so the models and the MJO and all that tells us what's forecast for the atmosphere, but what's really going on in the ocean? So this is sea surface temperatures, again from the DAO buoy array, West Pacific here, East Pacific here. These are anchor lines on the buoys that are strung across the equator, the whole way across the Pacific Ocean. The X's are the sensors on those anchor lines. We use a model to fill in the gaps where the sensors, where there are no sensors. And you get sort of this model that says, hey, we got warm water, 30 degrees in the West Pacific, reaching to 180 west, the date line. That's about where they've been. The 29-degree isotherm retrograding a little bit, pulling back to the west to about 171, 172 west. The 28-degree isotherm line holding about 160 west. 24-degree isotherm line more or less holding around. It was at 120. I think we're at 123. Okay, but you get the sense that over in here, warm water is getting shallower and shallower and harder to find, and that warm water is retrenching in the west and not pushing off to the east as much. And it becomes very apparent when you look at the anomalies, differences from normal for this time of year. You see weak, slightly above normal temperatures, 1 to 2 degrees centigrade, but where's the scale? There's the date lines right there. That's all focused on the date line. As soon as you get like south of Hawaii, what's that, about 155, something like that on the equator? Look at this. Warm water just disappears down at depth in the ocean, 102 meters, 200 meters down, and negative 4 degrees centigrade temperatures are building, and this is like a pocket of cool water that's working its way up and just cutting it into the heart of where normally you would expect warm water if El Nino was going. This is a clear sign of La Nina. No warm water at all left in the equatorial East Pacific. That doesn't bode well to be, you need warm water off of Ecuador, the Galapagos Islands, to be feeding the jet stream, to push it, like push it south through the Gulf of Alaska. We're not seeing any of that. If anything, it seems like all the energy is in the dateline region, but nowhere east of there. Here's a different model, same raw data, and it's basically telling us the same picture. Here's your ball of warm water under the dateline right there, but here's cool water just working its way into the East Pacific everywhere from about 145 west, so that's just a little bit east of Hawaii, the whole way into Ecuador, under a cool regime at depth. We're not talking the surface here, and we're seeing cool water appearing to be starting to migrate into the West Pacific Ocean as well. This is not a surprise, though, if you've been following our forecast. Let's dig on. Sea level anomalies, another way to give you a sense of what's going on temperature-wise down in the ocean, subsurface-wise. So this is from the JASON-2 satellite. This isn't actual temperatures. What we're doing is measuring for bulges on the ocean's surface. So the JASON-3 satellite, you strip out all the wave heights, the wind waves, the tides, and we see a 5 centimeter bump, and it's just on the equator we're interested in here, which means, okay, there's probably warm water at depth. Warm water expands a little bit, and that creates that little bump on the ocean surface. But the more interesting thing is here's the Galapagos, here's Ecuador, here Mexico, Central America. You see this triangle of basically negative anomalies, -5, -10s, all in here. That is the classic, must be cold water down here or cooler water, carving out, if any, instead of expanding, cool water contracts, creates a divot on the ocean surface, and this height sensor gives you the indication there's cool water filling almost the entirety of the East Pacific Ocean. And so here's the pattern: upper ocean heat anomalies, upper 300 meters of the ocean. This is the West Pacific here, East Pacific here. This is warm water, the oranges and reds, warm water from Kelvin waves, from strong active phases of the MJO back in October 2018. This is what, like Kelvin wave number 3 or number 2. Kelvin wave number 4 in early 2019 this year, right there, making its way from January into about April across the Pacific. And then a tiny weak Kelvin wave in May. And you see cool water starting to build, cool water in the West Pacific. Now here's even more interesting. In July, another mini Kelvin wave that didn't make it anywhere, didn't make it past a point south of Hawaii. And now yet another tiny Kelvin wave. It's just a ball of warm water. They're not even Kelvin waves because they're not moving. They're just, there's an active phase, the MJO, whatever warm water's left in the West Pacific, the westerly anomalies from the active phase, the MJO, pushes the warm water, but the active phases aren't strong enough, the winds aren't strong enough, there's not enough warm water, the warm water gets no momentum to really push east, and so it makes it to the dateline and just sits there and dies and doesn't go anywhere. And as a result, some of this is probably due to stronger than normal easterly winds over the East Pacific, causing more upwelling. I mean, lack of energy in the jet stream, lack of energy in the active phases of the MJO, and so you just get this standing wave of warm water that's slowly getting weaker and weaker and weaker. All that suggests is that there's some sort of La Nina trying to organize. So let's go take a look at the ocean surface, sea surface temperature anomalies. And this image right here is the best it's been in 2 weeks, and actually makes things look kind of good. I mean, here's Ecuador, here's Peru. You see, hey, warm anomalies along here, all filling north of the equator, off of Central America and Mexico, and you go, yeah, there's some pockets of coolness here, but it's not that bad. And you know, looking at this actually looks like the cool anomalies are fading out and warm water is trying to build. So here's sort of the head scratcher. Is that really what's going on? And is that model we looked at that showed the low pressure bias building on the dateline and going for the next 3 months, is this the harbinger of that? You know, because one would expect warm water to build as a result of that. But then we looked at just other data, the subsurface temperature data, that clearly indicated there's a lot of cold water under all this region. And we think this imagery, yeah, it looks nice, but it's way overhyped. And we'll go into that a little bit more here. Now here's the temperature trend for just the past 7 days. And you see, hey, warm water building in pockets. This actually looks better than it's been. Yeah, but it's been like a month of cooling in this area. And you can see now the interesting part is cool. The blues are cool. The cooling temperatures have made it the whole way to the dateline, according to this, just in the past week. So, I mean, this doesn't look horrible. You go, hey, it's warming, all kind of looks good. A little bit of cooling out here, but nothing too bad. But here's the backed off view of what's going on in the Pacific. And what do we see? A broad area cooling off of all of Chile and Peru. And then the trades, the presumption is you have high pressure here driving trades up the coast. And then they turn to the west over the Galapagos and are tracking the whole way to almost the dateline. I mean, this looks like pretty much a classic La Nina, not a super strong La Nina, but when you got cool anomalies the whole way across the Pacific, you cannot possibly go, oh, this is all going to magically disappear and somehow El Nino is going to return. Just don't see it at all. The ocean is taking up the slack where the atmosphere, again, the atmosphere is weak, it's not doing anything. The ocean has made up its mind. It's given up on the active phases of the MJO. There's no real warm water to do anything with, and it's appearing to be moving stridently towards some sort of a La Nina pattern. Here's the temperature trend in the Nino 1.2 region. This is the area right off of Peru and the Galapagos and Ecuador. You can, I mean, and it's always pretty noisy here. But you see, temperatures have been below normal. Today, we're at just about dead even. What is that? 5/1000ths of a degree above normal. But we've been down since June below normal. Probably in La Nina territory. Half a degree for 5 months. We're pretty close there other than this little batch here. But this is the noisy area. It's the Nino 3.4 area. That's the official El Nino monitoring region from 120 west out to 170 west, 5 degrees north and south of the equator. Today's value, a third of a degree, 0.376 below normal. But the trend is down, down, down. You got to get down, but we're not in La Nina territory yet. Half a degree for 5 months. We're nowhere close to that. We're not even at the threshold for a single day for La Nina yet. So, yeah, could this reverse itself? Well, maybe, but just given the magnitude and the amount of warm water that's cool water that's moving around in the eastern equatorial Pacific, I'd say the odds of some major rebound are pretty slim to none. So what's the atmosphere doing? What's it think is happening? Well, we look at the Southern Oscillation Index, difference in pressure between Darwin and Australia. When you have lower pressure over Tahiti, the daily index goes negative. Today we're at minus 5.28. I mean, that's not super negative. It's just been toggling between, negative and positive and can't quite make up its mind what it's been doing. So we'll say it's neutral. 30-day average, yeah, neutral. Not the active phase of the MJO, not the inactive phase of the MJO, just hanging around neutral. The 90-day average, the El Nino, La Nina sort of indicator, minus 6.33. If it's El Nino, it'd be down at like minus 15 or something like that. But you can see the trend is, we were down at 0.82 a month ago, and now we're at 0.6. So we're heading towards neutral. All right, so here comes the real mind blower. Where are we going? All the data we're seeing, from the ocean says, sure looks like La Nina. Looks like La Nina is developing. You look at the CFS model, though, and it says, no, low pressure bias is supposed to rebuild, and, So the model and reality are not in sync at all. And likewise, here is the CFS version 2, Nino 3.4 sea surface temperature anomaly, the forecast, the official forecast. Now, if you believe this, I mean, I'm really just scratching my head here. But anyway, all right, so what are we? End of August, temperatures are supposedly per the model, just a little bit above normal. That's about right. But look at this. It's supposed to actually warm. Can it warm? I mean, you saw all the negative temperatures in that region. I don't know how you're going to get to even a half a degree. This says about 0.45 of a degree above normal. Then going to about dead neutral in December. And then start warming up into El Nino territory late next spring. I would think, if anything, this curve should be going down like this. Now, let me be clear. I would be the first person to be able to call myself a liar and say, there's no way, that this is where we're going to go. But I don't want to mislead anyone and say, to say that you're even staying neutral or even biased weekly towards El Nino doesn't seem to make sense given what the ocean is doing at this point in time. And the atmosphere is like sound asleep, and there's no support for Kelvin wave development. So how are you going to get warm water building in the in the main El Nino monitoring region without Kelvin waves, the active phase, the EMJ, all that's like sound asleep, and there's no reason and no sense from any of the models that that's going to wake up. So the short of it is, I think this model is a bit overhyped. It's having a hard time dealing with the fact that the atmosphere is just undecided. It doesn't know what it's doing, and so it's making its best projection. I'm making my best projection saying that's probably not right. We probably should also go look at a bunch of other models. We'll do that next week and see if we can see what the consensus is and see whether this guy is maybe just an outlier and all the other models are sensing something else. But we'll save that for next week. All right, so the good news is there is sort of the transition to fall occurring. There is a little bit of swell heading towards the wise south shore. There is wind swell projected for the north shore of Hawaii. Not a whole lot for California. There's actually a little pulse of southern hemi swell that is coming for mainly Southern California for a couple of days later this week. Waist high type surf sort of thing. Best spots, chest high, shoulder high. So there's waves for the week. But long term, we're not seeing a clear transition to fall yet. We're not seeing the northern Pacific jet stream waking up. We're not seeing any big bombing gales. Maybe a little gale forecast a week out in the Gulf of Alaska. Long term beyond that, this whole mixed message thing between the models and what appears to be obvious reality in the ocean regarding El Nino or La Nina, though it appears that we're moving towards La Nina. We'll see. Right now, the long-term forecast for the fall is, we'll give it a average, but just given the complete lack of energy as we're moving into fall, when, if anything, we should be gathering momentum, we're seeing no signs of that, suspecting that it's going to be a pretty quiet fall at this point in time. And if La Nina does develop as you get into the Thanksgiving Christmas time frame, it could even get quieter after that. But it's a little too early to, say any of that's going to happen yet. So we'll remain hopeful and optimistic for the moment. So that's it for this week. We'll do it again next week, same time, same channel. Hit the like button if you like the video. Leave a comment if you like. Subscribe too. If you watch the videos and you want to get a forecast, subscribe. There's a subscribe button right down below here. There's a little bell. Hit that, ring that. You get notifications. A little email sent to you every time we update the forecast. Usually, in the Sunday evenings is when we typically try to do it. And so that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.